Here we are, already at the end, the last section of linear programming. So you should pause the video and read this information now. So linear programming is when we try to find the maximum minimum of something. So again, this is a lot with marketing or things like that. So we want to figure out what will maximize or minimize depending on what we're talking about, whatever the function is. So this is our objective function for problem number one, here are constraints. First thing you have to do is solve all of these for y. So I'm going to first subtract the x over. So I'm going to have 2y is less than or equal to negative x plus 5. And then I have to divide the 2. So y is less than or equal to negative 1/2 x, and then that would be plus 2.5. I'm going to leave it as a decimal just because it will be easier for me to graph. For the second one, I'm going to subtract the x over, so negative y less than or equal to negative x plus 2. Divide by negative. Remember what happens when you divide by negative? Sign flips, so this becomes a positive x minus 2. And then we have two constraints at 0 and 0. Because I don't have a lot of colors right now, we have to graph all these. I'm going to graph this one with a highlighter. So here's where y is 0. When you think about y, it moves left and right. So the equation for y equals 0 is this line right here. And it says y is greater than 0. So if I look at that, that would be above this line. Notice how when I am shading, I'm not taking over the whole spot because it's going to get kind of messy. Here, I'll need a graph where x is 0. X moves, the tick marks for x, when I do x like this, it moves up and down. So the graph for x moves up and down. So that's that graph. It also says x is greater than 0. So then that would be over here. So notice that now we are just working with the first quadrant. So now if I graph this first one, so positive 2.5, 2.5, so someplace right here. And my slope is negative 1, positive 2. So negative 1, positive 2. Negative 1, positive 2. Negative 1, positive 2. It's going to be a solid, or else I could go up 1 and then over 2. It's going to be a solid line. And it says it's less than, so it's someplace over here. Notice that when I do these, I make sure that my shading goes up to the line because that will help me. And the last one we have here is at negative 2. And my slope is up 1 over 1, up 1 over 1, up 1 over 1. So it's this right here. Okay, it says it's greater than this, so it's going to be over here. Now what you have to do once you graph them, and it can be kind of messy, is to figure out what the feasible region is. So the feasible region is going to be where all of these points intersect. So one thing I tell people is start where two lines cross and kind of go from there. So like right here, it looks like it's someplace in here. So my two lines cross at 0, 0. So if I follow just like my highlighter green line up until I need another point, looks like we have another point right here. Now I'm going to follow my orange line that I created. Looks like it crossed the blue right here. Now I'm going to follow my blue line that crosses my highlighter orange. I need to get some more color. So this right here is my feasible region. Right there. Now I'm going to write down all of these vertexes of my feasible region. So I have 0, 0. I have 2, 0. I have 3, 1. And I have, remember this is my y-intercept for orange, so that would be 2 or 0, 2.5. Okay, so that's step 3. Find the coordinates for each vertex. Then you want to evaluate to figure out what we're looking for. So if I look at the original problem now again, I'm looking at this equation. So I'm going to deal with that equation. And I want to try to maximize, okay? So I'm going to actually write my work over here. Here I'm going to rewrite all 4 of my points. And this is just how I personally solve the problem. You can solve it however you wish to, 0.2.5. Because sometimes people get confused, I go through and write this for each, because for each one of these points, I'm going to be evaluating that equation, the objective function that was given to you. Okay, so I'm going to write, this is my objective function, x, y. So I have a spot for my x and my y. So each spot, I'm going to plug in whatever points that we found. So this would be equal to 0. This is going to be equal, you can do this in your calculator if you need to. This would be 6, 7, and here would be 2.5. So now I need to maximize. So I'm looking at which one of these numbers are the largest. So this right here is the number is the largest. This is my maximum. So my overall answer would be 3, 1. Now when we get into actual type of word problems, the 3 represents one thing and the 1 represents another thing. So now I want you to try to do this one by yourself. I'm going to take it step at a time. So first plot your equations. So one thing this should have been less than or equal to. This should be less than or equal to, you should be shading below. So this is what your graph should look like. The purple is the line where x is greater than 2. That's over here. Where y is greater than 0. That's right here. My feasible region right now is this triangle right here. Now again, if I follow the green line to the purple and then follow the purple to the orange, so I'm looking at these points, at the points 0, no, I don't have 0, just kidding, at the points 2, 2, 0, at the point 2, 3, and the point 1, 2, 3, 4, 5, 6, 7, 8, 0. So I want you to pause the video and plug it in here and look for your minimum. You should get 2, 0 gave you 2, and that's my minimum. So my answer here is 2, 0. So now I want you to try to do this last one. Well, actually, no, this one's a little bit more tricky. So I'll work with you on this. So this is saying x. So there's where x is 2. Remember, here's where x is 2. So that's going to give me my straight line here. And then I have x is 6, 3, 4, 5, 6. So right here. It's saying x is in between that. It's saying x is larger than 2 but less than 6. So that would be this region. For my y's, here's where y is 1. Here's where y is 5, 2, 3, 4, 5. So I have this line and this line. And saying that y is in between there. Y is greater than 1 but less than 5. So it looks like already I know something's in that box. And I want you to finish off solving the whole shebang. So this line should have cut it off right here. So you actually have 1, 2, 3, 4, 5 different points. So when I have 5 points, here are my 5 points. I evaluate each one, and I'm looking for my maximum. So my maximum here was the 22. My answer here would be 6, 2. See, that wasn't that hard. You guys are geniuses. But also, have a great day.